morning to all of you. So today we will learn a new lesson, which is stack. Stack is in chapter 4. So previously we have learned linked list, whereby there are three types of linked list. The first one is single linked list, second one is double linked list, and the third one is circular linked list. So in this chapter, in stack, we are still going to use linked list. Okay, so it is very important for you to really understand how linked list is how linked list works. Okay, because we are going to use linked list in stack. So if you find that you are still having some difficulties on learning linked list, please make sure you do your own reference, you ask your friends or whatever it takes for you to understand linked list. So here we will go through the introduction first, and then we will learn about what is LIFO. LIFO means last in first out, and then stack operation, stack using array implementation, and stack using linked list implementation. Right. Stack is a linear data structure. Before this, in chapter 2, we have learned about linear data structure, and another one is non-linear. So stack is actually a type of linear data structure, meaning that in order for you to retrieve a data, you need to travel one by one. You cannot jump from one to another. For example, from this one jump to this one, cannot, because this is linear data structure. So it's similar to array. Okay, you need to travel step by step or one by one. Okay, stack is a linear data structure which follows a particular order in which the operation are performed. This type of order is called LIFO. Okay, abbreviation for last in first out. So what does it mean? Later I will show you some example. What does LIFO means? Every time an element is added, it goes on the top of the stack, and the only element that can be removed is the element that is at the top of the stack. So this is actually how the LIFO works. In stack, there are two main operations. The first one is to insert new element, where we call it as push. Okay, push. And then the second one is to remove an element, which we call it as pop. Alright, so we'll go through about LIFO, last in first out. So LIFO means that the last element added is the first to be removed. For example, the stack of rice balls in a cupboard, or the stack of books. Let's take a look of this example. Let's say we have a box here. Okay, we want to add a number of books inside this box. Okay, let's say we have 4 books here. Okay, previously I mentioned about two operation of stack. Push, which is to insert, okay, and then pop, which is to remove. Okay, let's say we have that box, a box, and then let's see the demonstration how to insert all of these 4 books inside this box. Okay, so the first book will be inserted, second book, the third book, and the last book. So that is push operation, which means we have that 4 books, Okay, we insert them into a box. And then how we do the pop operation. Pop is removing. Okay, removing all the books. So the books that we remove first is actually the book that has been lastly added. Okay, the yellow book is the book that is inserted at the end. Okay, and then this yellow book also will be the first book which I be going to be removed. So that is what it is mean by LIFO. The last in, okay, the last in will be the first out. The last book that has been inserted will be the first book that will be removed. So let's do the operation of removing the books, or pop. So this is the demonstration. So the first book that inserted, the last book that has been inserted is the first book that will be removed. Okay. Okay, if you see clearly, this book, okay, arranged in a on top of each other. So this is what we call a stack. Okay, an item that we arrange on top of each other, that is called stack. Okay, in programming, there are two ways of creating stack. The first one is using an array. The second one is using linked list. So if we are using an array, we need to define the size of that stack. Okay, or actually it is the size of that array. Let's say we declare the size of array is 4, or the size of stack is 4. So it will start with index 0 until index 3, because it uses the array indexing. Okay, so it must be started with 0. Okay, so before we insert any elements or items into a stack, we need to make sure that two things. Okay, for example, if we want to pop something to remove, we must make sure that the stack is not empty. Alright, because if the stack is empty, we don't have any items or elements to be removed. Okay, so to indicate the stack is empty, we are using this one. Okay, if top is equal to -1, which means there is nothing inside the stack. Later on, I will show you the example of the programming side. What is top equal -1 means, right? Similar to push, okay, or to insert, we cannot insert into an existing stack if the size of stack is already full. For example, here the size of stack is 4, okay, but all the 4 items are already occupied, okay, which means the items or the allocation are already occupied. So let's say we want to add another books, so we can't. So in the programming part, we need to do some exception handling. Okay, we need to do some verification to check whether the stack is already full or not. If it's already full, so we can't let any items to be inserted anymore. Okay, okay, so if we have done the verification For example, we want to push. Okay, push is insert. Let's say we want to insert these 4 books inside this stack. The size of the stack is 4. Okay, so what happened is whenever we add the first element, okay, the top here, okay, the top here will move to 0. Previously, top is equal to -1. -1 means that the stack is empty. Okay, top is similar like head in linked list, head or temporary node. So what does it do is actually it travel from one node to another node. But in this example, it travel from one array to another array. Okay, so actually what it pointing is, it is pointing to the index of the array here. So if the stack is empty, it will pointing to -1, which mean below 0. So whenever a new book is inserted, okay, the pointer, okay, will be moved up to the next index, which is 0, indicating that the stack already has one element. Let's say we insert the second book, so it will move, okay, the head or what you call as top here will move to the upper index, which is 1, until the last book. Okay, so now the new value of the new index of top is 3, meaning that the stack is already full. Why? Because the size of the stack is 4, so we can't add any books. Okay, now is for pop, or to remove from a stack. So the top here is pointing to index 3, meaning that the stack is already full. So what happen if we remove the last in book, okay, the last book that has been inserted here, which is the orange book. Okay, when we remove it, the top will be pointing to the lower index, okay, which is 2, indicating that it has 3 books left. So when it remove the second book, okay, it will be pointing to the another lower index, which is 1, indicating that there are 2 books left, until all the books are being removed. So whenever the stack is empty, the top will be pointing to -1, which is below 0, meaning that the stack is empty. Okay, like I mentioned before, we have 2 ways of declaring a stack or creating a stack. The first one is by using array. Second one is by using linked list. Okay, we go through the first one, stack by using array implementation. So this is the initialization of stack by using array. If you notice, we are still using struct. Why we are using struct? Because sometimes we need to have more than one elements, okay, whereby the elements are from the different data types. But in this example, we only have one element, okay, which is an int. Let's say when you want to create another stack, we want to have two elements, for example int and also float. Okay, so that's why we are using struct, because to accommodate the variety of data types. Okay, so for example, I'm just using one data type, which is int. At the first line here, I create a variable name max. Okay, max is equal to 3, but instead of using a normal variable declaration, I'm using a define here, meaning that define is something similar with constant. So meaning that this max equal to 3 is not cannot being easily manipulated. Okay, it's not totally can be manipulated, which mean the number 3 here is fixed across the program. If let's say if I declare the variable as something like this, int count equal to 3, for example, okay, by using a normal declaration here, the number 3 can be easily modified later on. Okay, but by using define or constant, the value here is fixed. Okay, you cannot modify it. So that is the justification why I'm using define here. Okay, and then I create another variable int count. Later on I will explain what is count for, what this count for. Okay, alright, so and then I create a struct name stack, and then there are two elements here, int top. Top is similar like head, the one that will be traveling from one index to another index. Okay, this is the top. Okay, int top, int list max. List is the data that I'm intending to store in this stack, so it is type of integer. Whatever that I'm storing here is integer. So max is the size of list. Okay, so in this example, I declare the size of max, the size of the value of max is 3, meaning that the size of list is 3. Okay, sorry, this one should be 4. Okay, this one should be 4 actually, because we have 4 allocation here. Okay, 0, 1, 2, 3, so there are 4. Alright, after that I create an empty I create another functions. So this function is used to create an empty stack. So the name of this function is create, and then I declare an instance of stack, which is t, and then I instantiate the top. Okay, the top equal to -1, which means the list is, or the stack is empty. Why it's empty? Because top is pointing to -1 below 0, so it means that the stack is empty. Right, after that I do another function which is named as empty. So what does this function do is actually to validate whether the stack is empty or not. Why we need to validate whether the stack is empty or not, because whenever we want to do pop operation, pop is removing, okay, removing any values inside the stack. We must make sure first that the stack is not empty. Right, we must make sure that the stack is not empty in order for us to do the pop operation. So if t top equal to -1, it return 1, else it return 0. Later on I will show you the full program. Okay, if it's returning 1, what happen? If it is returning 0, what happen? Okay, and then we need to have another functions to check whether the stack is full or not. Why we need to have this function? Because whenever we want to do the push operation, push meaning inserting, okay, inserting any values inside the stack, we must make sure that the stack is not full, okay, meaning that there is allocation left inside the stack. In case where the stack is already full, like this one, okay, we cannot do the push operation anymore. Why? Because we have the size of stack. So whenever all of the allocation has been occupied, we cannot add another more elements. So that's why we need to have a function to validate whether the stack is full or not. So this indicates t top equal to max, indicates that the size of array or the size of stack is full. So I want you to correct this one. Just now the max defined max is equal to 3, right? So the correct value is 4. So this time this one is actually max minus 1. Okay, why? Because it only reached 0, 1, 2, 3. Okay, so 4 minus 3, 4 minus 1 equal to 3. So whenever top is equal to 3, it indicates that the stack is already full. So whenever the stack is already full, it will return 1. Okay, this is the function for push operation. So the data that we want to insert inside the stack is from the type of integer. So whenever we want to do push operation, we must make sure that the stack is not full. Okay, meaning that the stack must be empty, or there's at least one allocation left. So first of all, we need to call the full function. This one, the full function, to indicate or to verify whether the stack is full or not. If it is full, it will return 1. If it's not full, okay, it will return 0. So just like I just mentioned now, if it returns 1, meaning that the stack is full, then we need to stop the operation. We cannot do any addition. If it is not full, okay, meaning that it returns 0, it will go to the else part. So it will run whatever inside this bracket. So it will ask the user to insert data. So after that, t top plus plus, meaning that top here will be +1. Okay, previously top is -1, so when +1 equal to 0, so the top will be pointing to 0. Okay, after that t list t top is 0, right? T top, because T top here it has been plus plus, so top is pointing to 0. So T list index 0 here equal to data. Let's say the user enter 10. Okay, so in index 0 there will be the value of 10. After that, count plus plus. This is the purpose of count. The purpose of count is actually whenever we want to display all the elements, all the value inside the stack. So previously I declare int count as 0, right? Okay, int count as 0. So when count plus plus, 0 will become 1. Okay, 0 plus 1. So whenever we call the push function, the count will be incremented by 1 value. Okay, and then pop operation. Pop is to remove any elements inside the stack. So how it removes? It actually removes from the top. Okay, from the last one that has been inserted. That one is the one that is going to be removed. So before we do the pop operation, we need to verify whether the stack is empty or not. If the stack is empty, so we can't do any pop operation. Why? Because there are nothing inside this stack. So if it returns 1, it means that the stack is empty. Okay, just refer to the empty function here. Okay, whenever t top is equal to -1, this is -1, 0, 1, 2, 3. Whenever it returns 1, meaning that the top is pointing to -1. Okay, when the top is pointing to -1, it indicates that the stack is empty. Otherwise, it will return 0. Okay, so whenever the stack is not empty, it will go to the else part. Okay, t top minus minus. Okay. Let's say we want to remove 10. Okay, and then currently the top is pointing to 0. So when we do the top negative, it will decrement to the next value, which is -1. So now the current top is pointing to -1, meaning that the stack is empty. Inside the main, we create an instance of stack. This is compulsory. And then we call the create function. So what the create function does is actually it will create an empty stack. Okay, by referring here, in create function, we declare, we instantiate top equal to -1, meaning that the stack is empty. So the first thing we need to do inside the main is to create an empty stack. this one. Okay. Okay, let's say after we create the empty stack, we want to add some element inside the stack. So we call the push function whenever we want to add elements. So let's demonstrate the data flow here. Okay, we create an switch case here. Let's say the user choose number 1. So number 1 for push is insert. So inside the push, we need to verify whether the stack is full or not. Okay, why we need to verify? Because we want to know whether the stack is full or not full. If it is not full, meaning that we still can add some element. If it is full, we can't add any elements. Alright, so the first one we call the full function, and then we verify, is it ttops equal to max? Max is 3, right? 3 or 4. Max minus 1. This is should be minus 1. I'm sorry, I'm not feeling well today. Okay, max minus 1. Meaning that here. So if ttops equal to 3, it will return 1. But currently the top is pointing to -1 because just now we already create an empty stack. So what it will return is actually it will return 0. Okay, so this condition is false, so it will return the else part, which is 0. Okay, then because this condition is not met, it will go to the else part. So it will ask the user to insert any data. Okay, let's say the user enter 10. Okay, after that top plus plus, the top will increment by 1, so it will be pointing to 0. Okay, and then t list ttop. Ttop is 0, right? So in list 0, list is actually an array. Okay, list 0 equal to data. Data is 10. Okay, so let's say the user wants to add another elements inside the stack. It call again the push function, verify again, is it the stack is full? No. Okay, because top is not equal to 3. Now top is equal to 0. Okay, and then it will return 0. Okay, so this condition is not met. Is it full equal to 1? No, it's equal to 0, so it will go to the else part. Then it will ask the user to insert any value. Let's say the user insert 20, and then top plus plus, 0 will be incremented by 1, and then list 1 equal to data, so data is 20. Okay, so now top is pointing to 1. Okay, let's move on to the second part, which is pop. Just now the user do two push operation. Okay, the first one the user insert 10, second one the user insert 20. So next the user wants to remove. So whenever the user wants to remove some elements, the first element that will be removed must be the element that on top, or the last element that has been inserted. So in this case, the recent element that has been inserted is 20. So in case 2, let's say the user key in number 2, so it will go to the pop function. So we need to verify whether the stack is empty or not. So if empty equal to 1, is it empty equal to 1? So let's go to the empty function. Is it t top equal to -1? No. Okay, t top is pointing to 1, not -1. If it's -1, meaning that it is an empty stack. Okay, but now it is pointing to 1. So here it will return the else part, which is 0. Okay, and then it will go to the else part, t top minus minus, meaning that the current t top will be decrement by 1. So 1 will be pointing to 0. Right? So this is the function to print out all the value inside the stack. I forgot to mention one thing here. Count minus minus. So whenever we call the pop function, the count will be decremented by 1. Okay, let's say just now we call push 2 times. There are push operation for 2 times. So the starting value of count is 0. So when push is called 2 times, so 0 will become 1, 1 will become 2. Okay, so later on, well, when it calls pop function, it will decrement by 1. So the current count now is actually 1. I hope you can imagine, okay, the transformation of the count value, okay, from 0 to 1, and then to 2, and then goes back to 1 again, all because of this. Okay, so whenever we call the pop function, the count will be decrement by 1. Whenever we call pop function, it will increment by 1. So this is where we determine the size of the current stack. Okay, because we have done several push and pop operation, we need to keep track what is actually the size of that stack. So that's why we need to have this count variable in order for us to know the current size of stack. or the number of elements inside that stack. So here it will print out only the latest number element of the stack. Alright, so I equal to 0, I less than count I plus plus. So it will display stack I is following to this one. Okay, stack 0 equal to t list 0. Okay, and that will go up until the latest value of count. Right, exercise 1. So I need all of you to do this exercise as a proof of your attendance for this lesson. So for exercise 1, you need to create a stack using implementation using an array implementation based on the following operation. The size of array is 5. So you need to do push operation to insert this alphabet A, B, C, D, and then you need to do 2 pop operation. After that, you need to do push operation to insert E, and then you need to display the latest element in stack. Okay, we move on to the stack, but this time is by using linked list. So it's similar to single linked list actually. In this example, we have only one data. Okay, struct node next. This is the tail. We are pointing to the next node. So the benefit of stack by using linked list implementation is actually it doesn't have any limitation of size. As compared to array, we are limited in terms of size, but this time it is unlimited. And then we create a node, another instance of node, okay, called top. This is the one that will be pointing or will be traversing from one node to another node, equal to null. So this is outside the main, outside the main. Okay, so we need to create the null node, okay, or the top node, which is equal to null. So as similar to stack using array, the top will be pointing to the node at the bottom. Okay, the node at the bottom. So as compared to array, we are pointing to -1, right? We are pointing to index, but this time if it is empty, it will be pointing to null instead of -1. Okay, this is the push operation. Where we receive an integer value here. We create a new node. This one is compulsory. New data equal to value. So let's say the value is 1 here. So we need to define whether the stack is null or not. Okay, node data equal to value, this one. Okay, if top equal to null, meaning that the stack is empty. Okay, if the stack is empty, New node next equal to null. New node next equal to null. Okay. Else. Okay. Else part will be explained on the next slide. And then it will, after it will run, it has run this one, it will go to this one. Top equal to new node. So top equal to new node. So whatever is inside this new node will be transferred to top. Okay. So top equal to null is actually means that whenever the stack is empty. Okay. So the first value that you are going to insert is actually the first value. Okay, let's move on to the next one. Still value equal to 1. So let's say in the stack we already have two elements, two value, 2 and 3. So this is the first element that has been inserted. This is the second element that has been inserted. We want to add the next element, which is 1. So by right, top is not null. Top is not null. Why? Because top is actually pointing to the latest one here, which is 2. Okay. So new node next equal to top. New node next equal to top. So it will be pointing to top here. Because this and this are sharing the same address, so whatever that going happen here is also applied to here. So now top equal to new node. Now top is pointing to new node. Okay, pop operation. If top equal to null, meaning that the stack is empty, so we don't have any elements to be removed. However, if the stack is not empty, it will go to the else part. So in this example, I just jump into this one, the else part. So let's say the top is pointing to the last element. This is 1 actually, not 2. Okay, this is 1. Later on, I will do the correction on this one, right? Okay. What happened after that? Top equal to time next. Okay, before that, okay, we have top here pointing to next. Then we create a time node which is also equal to top, similar. So these three values are similar. These three nodes are sharing the same address. And then execute this one, execute this one. Top equal to top next. Top equal to temp next. Temp next. Okay, next is pointing to this one, right? Okay, whatever that is pointing to, if this node is pointing to this one, meaning that all these nodes are pointing to the same address. Okay, because all these three are basically sharing the same address. So top equal to temp next, and then free temp. Free means it will delete this one from the memory. So because this and this are sharing the same address, it will delete all of these two nodes together, right? Okay, this is the display function to display all the uh, element inside the stack. Okay, let's say we have these three elements inside the stack. So if top is equal to null, meaning that the stack is empty, just jump into the else part. We create a temp node which is equal to top, and then what happen is we do the while to what we call as to travel, okay, between each node, while temp next not equal to null. Temp next here, okay, temp next is pointing to here, not equal to null, okay, which is true. So what it will do is it will print temp data, temp data, okay, so it will print 1. After that, temp next, temp equal to temp next, so temp will be moving to the next node. Okay, and again it will verify again and again until this condition is false. Okay, finish. Okay, thank you for your time. So please don't forget to do the exercise 1 as approved for your attendance. Okay, so if you have any further questions, please let me know. Either you can WhatsApp me, or you ask in the WhatsApp group, or also you can ask in Otter. Okay, so until then, we defer the class for today until we see next week.